Hello, this video shows how a part is programmed in Capstone. We will see how Capstone helps you easily reduce cycle time, generate shop documents automatically, and generate CNC programs. Our sample part has 5 operations: rough facing, rough turning, finish turning, and threading. We first select the workpiece material, which can be from a generic list or from a material standard. We then define the safety area around the workpiece. This helps Capstone determine the shortest path with automatic collision avoidance. We then specify the part number and name, operation number, etc. Doing an operation in Capstone is very easy. It involves only 3 basic steps. Step 1: draw the part and the blank. Step 2: select the tool and the operation. Step 3: tell the tool where to do the operation. In step 1, we will draw and define our workpiece. We will import the part and the blank shapes from an existing CAD file. They can also be drawn in Capstone's inbuilt CAD. We now tell Capstone which is the part shape and which is the blank shape. In step 2, we now specify the tool and the process. Select the operation. Select the proper tool. In step 3, we tell the tool where to do this operation. Just click the start point and the end point of the area to be machined. Cutting parameters and various other parameters are selected automatically based on the operation, workpiece material, and tool. We then add more operations in the same manner. Select the operation, select the proper tool, specify the machining area. In threading, all you do is select the type and the size of the thread. The depth of the thread is determined automatically and used to determine the number of cuts and first depth of cut in the threading cycle in the CNC program. Now we will check the toolpath simulation for any problems like collisions and gouging. The simulation shows that the toolpath is fine. We have done 5 operations. Notice how easy it is to use Capstone. Just watching this video, you probably already learned how to use it. We can see the 3D view of our part. We now select the machine on which we want to cut the part. Now we'll see how we can reduce the cycle time and machining cost using the Moneymaker feature. This unique feature helps you to reduce your cycle time and machining costs. This table shows all operations, their tools, cutting parameters used, power consumed for the operation, and the power available on the machine. It shows the cycle time and machining cost of each operation. It also shows the total cycle time, the weight of chips generated, machining cost, etc. Let's see if we can reduce the cycle time by using the spindle more efficiently. The table shows that the second operation takes the most time and is the most expensive operation. The cycle time is 14 minutes 55 seconds and the machining cost is 73.6 rupees. We have 14.8 kilowatt power available, but we are actually using only 3.1 kilowatt, seriously underutilizing the spindle. To use more cutting power and reduce the cycle time, we can increase cutting speed, feed rate, or depth of cut. Here we will increase the depth of cut because this has the least effect on tool life. You'll notice that the table also shows the maximum depth of cut possible with the tool holder and insert that we have selected. Let us increase the depth of cut to 6 millimeters. The spindle power required is more than available. You can see that it is highlighted in red to indicate the error. Let's try a smaller depth of cut. This is too low and we can still increase it a bit. This is the correct depth of cut. You can see that the required power is just less than the available. We have reduced the cycle time from almost 15 minutes to 5 minutes 46 seconds and the machining cost per part from 73.6 to 27.9 rupees. That is a reduction of 62% with just a couple of minutes of using the money maker. Now you see why we call this feature the money maker. Moneymaker also gives you the scrap sale value and the energy consumption, so you get an accurate machining cost. You can now generate the CNC program. This program does not require any editing and can be transferred to the machine and cut without any dry run or single block check. Capston's auto collision avoidance and auto gouge prevention ensure that your part will come out first time right, without any trial part rejections. We'll now generate shop documents that can be filed for future reference or given to the machine operator. The cycle time sheet shows us the overall cycle time, cutting time, haircut time, tool change time, and other miscellaneous times like chuck open close. Capstone generates cycle time very accurately, ensuring that you will be able to make very accurate job quotes to your customer. All documents can be exported to PDF, XLS, and XML formats. The tools list can be printed out and given to the machine operator. The tool layout sheet shows the tool path and tool in each operation. It can be printed out and given to the operator to understand how the program works. This is a rather complex part and it took us just 5 minutes to generate a program with a low cycle time and to generate shop documents automatically. You do not need to know any programming and you can learn how to use Capstone in just 4 hours. This is the power of Capstone.